Доброго ранку. Один. Не чути? Окей. Доброго ранку. Компанія EPAM рада вітати вас на сьогоднішньому івенті на EPAM Java Meetup English Edition. І оскільки це English Edition, let's switch to English. So, today we have 3 speakers, despite that we initially expected to have 2. Today, Роман Шрамков, Technology Director of EPAM and Head of Java Competency Center, will be presenting top things that Java developer has to know in 2020. After that, I, will be presenting a Microservice landscape review of 2019 and what to expect. And last one, but not least, we have our guest speaker, Sergey Bishir from Logica, who will present also one more topic related to microservices. So it's microservices, the fun dominance, and Istio Service Mesh, the new hope. So why English? English because EPAM is a global company and it has offices in more than 27 countries, and we are rapidly growing. We are about 30,000 engineers, and of course, English is our official company language, and this stream is global stream, so people from other offices and people on YouTube and Facebook are watching us. Another thing why English, it's because wants to give Java engineer additional chance to practice their English. So practice for speakers, practice for attendees. We are 10 minutes late with our agenda. Hopefully we will catch up, but still now we are live. So Roman Shraмкov will start right now after me ending this. Hopefully we will catch up with my speech at 11:50. So please don't miss this if you are watching us on YouTube. So that's it. Welcome everyone and let's start.
Hi guys, can you hear me? Let me share my screen. I hope you can see my presentation. Just a second. Can you please show me the monitor, because I cannot see what people see on the screen. Okay, yeah, so that's my work copy. Let me switch to another mode. Okay, now it should be okay. So guys, today I was going to talk with you about top things or top trends which Java developers should know or should be aware about, because from my point of view, knowing and understanding trends is a good way to stay in shape, and is a good way to properly develop your skills and build your career. Couple of words about me. As Oleg already said, I'm head of Java Competency Center, and in the Competency Center we yearly analyze trends and analyze technologies which are used by our clients on our accounts. And based on this, we built some educational recommendations for our employees and our engineers. Also, I'm a solution architect, so with primary background in Java platforms. That probably means that my level of view is a bit high level, and my understanding of trends might be a bit high level for developer, and I can touch a lot of areas, a lot of technology stacks. Hope nevertheless that this information will be still useful for all of you, because we will discuss discuss how well each technology stack is trending right now, and how often it's used on our projects in EPAM. This again might be quite interesting information. And as a director of technology in Ukraine, currently I'm focused on solution architecture discipline development and on technology consulting development. So we will not touch these points this time, but maybe on some next meetup we can discuss these disciplines as well. So what we will talk about, when I analyze similar articles from the internet about trends and about things to learn in different years, I discovered that a lot of kind of obvious things for me are listed there, and that's why I decided to start from a stack of choice for Java developers, or again from EPAM perspective, and decided to list those technologies which, from my perspective, everybody should already know, or at least technologies which should be in the short list for learning for each Java developer. Then I will present my understanding and understanding of my colleagues, solution architects who are working with different clients in different domains, general trends in industry which are applicable to Java platforms or digital platforms which are written in Java or based on Java, JVM. And for each of such trends, I will provide some reasoning about why it happens, how it might affect our work, our technologies which we use. And for each of these trends, I will try to give you some particular things to explore in this area. I must say that probably the whole list would be quite wide to cover it in one next year. So basically you will need to do some work as well, and to choose those technologies and those areas which are more relevant for you and more applicable for your work. So how we do it, I already mostly described this. Each year we collect statistics about use frameworks in our company, and we analyze trends based on experience of our top experts and top solution architects. Working group is compiled and works on something like technology radar. In this presentation, it will be kind of preliminary version of this radar for this year. Who is Java developer? So basically Java is very wide, and you understand that many people are doing absolutely different things, starting from Android development to enterprise applications or systems development, desktop development, etc., even embedded. And in this presentation, I focused only on Java web development, because right now digital platforms, modernization, and building own digital platform for different companies and getting digital overall is probably a primary trend, and it still goes, and that is really good, because that's why we all have a job to do. And basically web platforms, one of those, the biggest and most wanted, which are currently built for our clients. who are EPAM clients? Another interesting question. So we are quite big company taking in Ukrainian scale, and that means that we work with other big clients. So most of our clients are big enterprises, which happily use Java as a platform of choice for development because of known reasons. A lot of open source software, a lot of free software, a lot of engineers who know Java, etc. But this means, from another hand, that most of EPAM clients, they tend to use technologies which are proven, which have good support and can be quite reliable in production. That doesn't mean that our clients doesn't use cutting edge technologies, doesn't do any R&D, they do, but mostly if we are talking about digital platforms, that should be something really well crafted, which is already proved in production. Understanding that, going further, and let's discuss stack offer choice for Java. It was a surprise for me that in one of the articles it was advised to learn Git in 2019. So I hope that most of you already use Git in your projects, because of course, there are other version control systems. They are still used in a variety of projects due to many reasons. But from my perspective, any new project, any new green development should use Git, because probably this is the only version control system which will be developed further, and infrastructure ecosystem around this version control system will grow. We can see GitHub as an example, or GitLab as an example. These platforms are actively growing and providing new and new services around Git as a repository. Another thing which is very important, trust me, it's new Java versions, because many clients already come to us, and first question which they ask, okay, how many developers in your company already know latest Java version? So I list here Java 11 because it's a long-term support version, but probably you should not limit yourself to the 11. Still might just focus on it and learn latest version as soon as they appear. At least you should be aware about features of Java 11, and when you come to interview to EPAM, probably you will be asked questions about latest version of Java. Same thing for Spring Framework, because Spring Framework right now for us is definitely framework of choice, of platform of choice, because Spring is quite wide already. And again, following requests from our customers who already start greenfield development from the latest technologies, you probably will be asked about Spring 5 and Spring Boot 2 as the platforms for development. So basically, most of new features, at least you should be aware. At least you should be aware what is Spring 5, and at least on your pet projects already tried some features of it. Maven or Gradle. Maybe a couple of years ago or a year ago, I was really surprised that actually Maven is more widely used in Java world than Gradle, because when Gradle arrived, in my opinion, it was better than Maven, because it was more flexible, given possibility to not only declaratively describe builds, but do it in a programmatic way, as many developers get used to. But actually, the fact is that Maven is still here, and starting a new project, you can absolutely choose Maven as your build tool, because it's already quite mature. It's used on good amount of projects in EPAM and outside, so it would be a safe choice. Still, if you prefer something new, you can use Gradle. It's another good build tool. Two of these, I guess, should cover all your needs in building. JUnit and JUnit 5 and Makito. That's for unit tests, and again, that's frameworks of choice. You either should already use it on your project, or you should be aware about JUnit 5 and how it differs from previous version. I'll talk about Kotlin a bit later. There are different stacks, good stacks which are out there and which I personally like. For instance, it's Lightband stack. I follow this company, Play, Arc, Alagom, and other products which they produce. Still, in enterprise segment, Lightband stack is still not so common as Spring stack. So basically, knowing the Lightband, Play, Arc, and all this stuff is good thing to do, but more likely when you come to big companies, Spring will be kind of de facto standard. It usually depends from the project, but you should consider Spring as a safe choice, and Lightband is a choice of interest. If you really like this stack and if you like to focus on it, you will definitely find some projects which use it, but I bet that it won't be so many projects and positions like with Spring. There are another smaller frameworks or smaller platforms which are out there and which are used in Java development, like Vertex and like Netty container. And those are also used, especially in different microservices setups, when each service can have its own approach to and its own architecture, but again, taking into account that Spring and Java itself are pretty good cover all different aspects required for development, even including reactive development. The latest version of Spring, it's not so widely used on enterprise projects, maybe on some smaller modules, maybe on some smaller services. Still, something good to know, something good to learn for your own personal development, to understand the concept, understand the difference between bigger frameworks and lightweight frameworks. So do you need to learn another programming language? The answer is, of course, yes, you should. But you should probably, if you invest in your time in learning properly, understand how different programming languages trend. And basically, what I can say here is that Java, it appears that Java is quite well goes on demand from developers, and in many cases developers just choose Java as a programming language, and they're absolutely happy with that. A lot of projects use Java, pure Java, core Java, and never bothered about any other programming languages. Regarding Scala, we have Scala competency in the company, and there are many projects which use Scala, but again, Scala, it looks like Scala became something like very niche skill, which is used for some particular cases by some particular teams. But in most enterprise projects, when you need to build something really big, when a lot of people involved, when there is some unification and standardization involved, Scala is not really a good choice. So basically, just like with Lightband stack, if you love Scala and would like to work as a Scala developer, you definitely will find the work. But with Java, it definitely will be much more opportunities. And another interesting language which was actively promoted last year and maybe year before this is Kotlin. They really make several interesting partnership, and in particular with Gradle, Google, and Kotlin probably is one of those languages which really made it to production. And again, based on EPAM statistics, Kotlin is actively used on productions for Android development. So basically, Kotlin, I would really recommend to learn for you as another programming language for JVM platform. And taking into account how other languages trending, right? You definitely should consider learning JavaScript if you don't know it already, or Python, because those are the languages which are currently used in very interesting scenarios like machine learning, AI, etc., and extending your vocabulary with these languages, you will definitely will see more opportunities to develop further. Regarding general trends, let me just check our timing. It's not so good. Okay. I will just go a bit faster. So general trends. What will affect Java developers and digital platform developers in several years, following several years? Cloud platforms. Basically, previously, most of our development was based on open source software, which was installed in on-premises basis, and that was like a core crucial element of Java and Java platforms. Right now, this focus is actively shifting by cloud providers, because clouds became not only a source of flexible infrastructure, but they became really complete environment for software development with services, specific services which are provided, and which in many cases even are not covered by any open source software. So everything is going to the clouds, and the cloud providers start to compete for companies which host their platforms in their cloud, and for developers who develop applications for their platforms. And basically that means for us, for developers, that if before we could consider cloud as a secondary skill and Java as a primary skill, it will trend otherwise. Your cloud skill in some particular platform will be considered as a primary skill, because knowing and understanding what services to use in Amazon or Azure will be even much more important than knowing how to write your own service in the same cloud, for the same cloud platform. So all of us will be to some extent cloud developers with time. Microservices and containers. Microservices are hard, and it's not so easy to build a really good microservices platform, but still this is de facto standard right now for platform development. And most of the clients who start their transformation projects, they start from understanding how they could split their existing application to microservices and build some kind of reusable microservices platform. So Martin Fowler's recommendation, start from the monolith and then go to microservices, probably is not relevant anymore. Start from microservices, know how to do them well, and that's something that we will all probably do for the next 5 or even more years, go into microservices. Another very big trend is security. You probably all heard about different cases when software is hacked and some sensitive information is leaked, and companies spend a lot of money trying to reduce their loss and reduce damage produced by these hacks. And that means for developers that security will be in trend, and secure development will be in trend. Right now, this means that all and different security testing services established by different companies. So many companies, or especially big companies, already have some security departments, including EPAM, by the way, which constantly test their applications, their infrastructure for vulnerabilities. And that means that for developers, understanding of how to write secure software will become more and more important. And this will be on demand. You definitely should learn how to do secure programming. Reactive and secure S and event sourcing. I wouldn't say that, again, from EPAM perspective, this pattern or this architecture is more popular, for instance, than microservices, or even the same has the same popularity. But there is a constant demand on such kind of architecture and good understanding how such kind of architecture can be actually built. From my perspective, building reactive systems even more complex than building microservices system, because there is no end-to-end way and understanding how to build it, starting from user experience when user starts to interact with the system using some kind of events or messaging, because our users are not familiar, are not get used to such kind of communication. And back to databases, when in many cases reactive communication with databases are not actually possible. So the whole end-to-end stack is not built yet, but definitely there are some pieces of systems which are written using this approach, and a good developer should know and understand how this should be done right. And you know, another trend which we see a lot is that many customers come back to us with requests to full stack developers. So basically, it's not just enough to be a good Java developer, know Spring and write code in Java. In many cases, various, especially like startups projects, they require much more broad skill, and being a full stack, being a person who is not scared to read another language, to fix bug in another module which is written in another language, or to debug Jenkins pipeline and fix some problem with pipeline which usually DevOps fixes, or even can quickly program some simple form for front end using Angular or React as a platform. Such person will be really valued by companies and by the client. And that means that for us, for developers, that means that we should not be limited to our stack. Let's just try to explore other parts of the stack, like DevOps tools, like front-end development, like security. On these slides, I just listed almost the same, which I tried quickly cover like this, and on the previous slide, so I'll just list. Very interesting slide here. It's right scale report for the previous year, and we can see what cloud providers are actually most popular and widely used by different clients. And on the first place is Amazon Web Services. As usual, nevertheless, Azure grows really well, and you can see that it's relatively close to AWS already. And Google Cloud is trying to get to the same position. They try to be a bit cheaper. They try to provide some unique services and try to get their audience. In general, trend in the industry is that most of enterprises, big companies, they use not only one cloud, but they use several clouds to host their infrastructure, and they use some on-premise solution to host some critical or sensitive data and applications inside. And basically, for developers, that probably means that if you a really good professional in one of the cloud and already became a cloud developer, you might consider learning another cloud at least to understand what is the difference and what are the benefits of different solutions. Because many companies, they does not focus on only one single cloud. A lot of companies use several clouds, in some cases to avoid vendor lock-in, in some cases to optimize costs. Microservices already told you, and for microservices, for me, probably one of the most important things to understand is that microservices and containers usually considered together, and it looks like Kubernetes. It's right here. It looks like Kubernetes starts leading in the game of container managers. If you aware, Pivotal recently claimed significant revenue loss, and that means that Pivotal Cloud Foundry doesn't, as one of the primary competitors to Kubernetes, doesn't do it so well, and Pivotal couldn't get customers to their digital platform. There is another major players, but they are not so popular, and they are not so growing. And Kubernetes, one of the platforms which is actively developed by the community and actively growing in use. So basically, if you are not using Kubernetes still, you probably should consider this. And it won't be easy because there are some issues and difficulties with Kubernetes. This is a platform which requires some expertise and knowledge, but once you invest into it, you will definitely be in a good position, because in many projects, Kubernetes will be used as a primary way to manage containers. That's, again, in my opinion, might not happen actually. For security, why I put it here, this is very high-level recommendation, but still on many interviews when I talk to Java developers or even architects, many of them doesn't know about OWASP top 10 vulnerabilities and doesn't understand how to address them with defensive coding practices. Taking into account that importance of security is growing, I would strongly consider many of us to reiterate what are those vulnerabilities, what are those defensive coding practices, and at least be aware and preferably use it in your day-to-day coding. And while penetration testing is kind of ultimate tool to find vulnerabilities, which in many cases done by specially prepared people, educated people, there are things which can be done on continuous or regular ways. And I'm talking about SAST and DAS. Static application security testing and dynamic application security testing. There are some tools which can do for you static application security testing, which is basically analyzing your code for possible security bugs or vulnerabilities. And usually this well covers OWASP top 10 vulnerabilities, and SonarQube, for instance, provides a separate model to do this. And there are tools for dynamic application security testing. That means that you deploy your application somewhere and you point those tools to the application, and this tool checks known possible vulnerabilities at runtime. I bet that in most of the CI/CD pipelines, SaaS and DaaS will be those in which teams will be work in the nearest future. So basically, again, these topics are very good to discover, and I'm not giving here any particular approaches because there are a lot of tools and companies which are doing this, and this will depend on your demand. Being full stack, I already described primary frameworks for front-end React, Angular, Vue.js. From my perspective, React is the most important and the mostly used right now. So basically, knowing only one this framework will give you a good chance to make some good front-end. Terraform, Ansible. There are, again, a lot of DevOps tools out there. I would recommend to learn Ansible if you have such possibility. And another interesting thing, a lot of cloud providers, actually all major cloud providers like Amazon, Azure, and Google, they invested intensively into development infrastructure or services for developers. And each of them provides services to build CI/CD, and that is another way to build your pipeline based on cloud, which you might already use. So I strongly recommend you to look at these services. It's Amazon CodeStar, Azure Pipelines, and Google CI/CD services. They are very simple, in many ways simplified to allow quickly set up CI/CD pipelines, and I think that you will enjoy this experience, especially comparing to Jenkins. It's the lack of documentation and sometimes of lack of clarity in instructions. These services are quite good, and you even without any DevOps DevOps experience, you may try them and succeed in pipeline development. So guys, that was my last slide. I hope you enjoyed this talk, and hope that something was useful in it for you. And I'm not sure if we have time for question. I guess not. Guys, who are moderating?
Guys, if there are any questions, please ask. I believe we can spend up to 5 minutes. YouTube watchers.
Hey, can you hear me?
Roman, we can hear you. Can you hear us? Roman? Okay. We have technical issues.
Okay.
I think that there will be no questions, unfortunately. unless Roman can hear us. Roman, can you confirm?
So I can see that hands are raised, but I cannot hear anything, guys. So
okay, it's a pity. Then I guess no questions. Sorry. Text to Roman. I don't think it will work. It will take a long time. Okay, let us end it. Thank you, Roman. Okay, it's 12:00 and we are starting our next speech. Our next speech is Microservice Landscape 2019 and beyond. So please take your places, and everybody who is watching us also get ready. So let's go. What we will be speaking about. So agenda. Our agenda. First, let's get acquainted. Just briefly a few words about myself, so you will know my experience, background, and so on. Next thing, basically next two things are pretty important. We will set up an agreement on what we are speaking about and what we are not speaking about here. Next, very brief recap of what is a microservice and why it is important, a bit of history of microservices. Then we will speak about typical microservice. Roman said it's complex, I'll try to prove him wrong. We will speak about so-called cloud native applications in 2019 and beyond. We will speak about building blocks, very high level. What do we need to have our microservice, best breed microservice running? And pretty subjective thoughts on what will be after 2019. So let's start. My name is Oleg Fazulin. I'm working for EPAM Systems for 11 years. Currently on the position of software engineering manager, which doesn't mean that I'm hands-off person. Actually, I am working in different roles depending on the need. So it is team lead role, it is delivery manager role, it is solution architect role, wherever I am needed more. Currently I'm sharing all those three. So my engineering experience is about 15 years. Last 5 years I am building microservices for various customers and actually running them in production. My primary skill is Java, which doesn't mean that I am not looking to other technologies and DevOps practices and so on. Okay, pretty important thing, what we are speaking about. So I want this presentation to be a discussion between you and me. So we have two microphones here. Don't hesitate to interrupt me, just raise your hand. You will be given a microphone and you will be able to ask your questions. Please don't ask questions without microphone because people online won't be able to hear us. So, our first point, we will be speaking about building microservice as end-to-end solution, like all the components you need to get it running in production. We will be focusing only on industry-adopted components. Our microservice landscape is huge. It's terribly huge, and it's not possible to cover it even in a day, not speaking about 40 or 45 minutes talk. So only industry-adopted components, a bit of my subjective opinion, of course, and so on. So later in the end, we will speak about how microservices will look like beyond 2019, maybe next 2 or 3 years, and that's it. Next, also very important thing, so what we are not speaking about here. So we are here not to compare technologies and frameworks. We are not discussing any technologies or frameworks in depth, just because we don't have time. We are don't analyzing feasibility of particular framework to your particular task. We are don't making any strange weaknesses, opportunities, or threat analysis of any framework. We can do everything, but later on the coffee break, okay? Not in scope of this speech. Okay, and a little calibration. So I want to ask you a few questions, just to understand how to deliver the speech better. So can you raise your hand who actually deployed microservices to production and supported them? Okay, I would say 10 people. Who just developed microservices but never deployed them to production? 3. 4, 5, okay. And read or heard about microservices, I guess everybody else, about 25 people here. Good. Can you raise your hand who is Java engineer? Almost everybody. Non-Java, maybe, okay, 5 people, good. Good. So let's start the actual speech part. So what is a microservice? If you will Google what is a microservice, you will find a lot of different terms and explanations. Basically, microservice is an architecture pattern. It's kind of approach how you build your software, how you run it, how you deploy it. So it says that it should ideally do one thing and do it well. It should focus on business needs. It should be easily wrapped into containers and easily deployed, easily scaled, replaced, and so on. So basically, microservice is something tiny that solves one question. Solves one problem, one business need. If you think that microservices are new, you are terribly wrong. Microservices have been there for a while. This chart is about 14 years from now. Say we're on the radar even a bit more, but still. First, microservices were in micro web service term was mentioned on software engineering conferences in 2005. In 2010, Netflix, everybody knows Netflix, had their entire stack running microservices on AWS platform. And word microservice, term microservice, was just introduced in 2011. In May of 2011, Dropwizard, first release of Dropwizard. I think everybody heard about Dropwizard, at least heard, maybe not used. It was predecessor to Spring Boot, at least a concept. So microservice term, as well, industry standard, let's say, was established in May 2012. And in the same time, in 2012, Netflix began to open source its components. So Zool, Erica, all other. In the same time, in 2012, microservices appeared on TopWorks technology radar in their SS category. So it's kind of wide trial. I believe everybody knows about our first technology radar. So next big thing for microservices was 2013, where Docker arrived and Spring Boot 1.0 was released. In 2014, Kubernetes, initial release of Kubernetes was introduced. And in the same time, microservices moved from access to defined inter-source technology radar. In March 2015, Spring Cloud 1.0 was released. Also later bit, Cloud Native Computing Foundation was established by Google, mostly to support its cloud platform, Kubernetes platform. In August 2018, we are skipping here a bit of time. The Cloud Native Computing Foundation changed leadership from Google to community. So now it's community-driven organization. And three last things here. So in October 2018, Micronaut, it's a framework, a competitor of Spring and Spring Boot, was introduced. In the end of the speech, you'll see why it's important. In the April 2019, 2 months ago, Micronaut was listed as SS on the fork technology radar. And in May 2019, last month, GraalVM reached its first public release, so version 90.0, but still its first stable production-ready release. Okay, so that was a bit of history. Microservices. how microservices looked like in 2012, 13, 14, and a bit of 15. So easy. Easy, it was Spring Boot, it was Netflix stack, period. If you go deeper a bit, it was mainly historics for circuit breaking. Everybody knows what circuit breaking is. Can you raise your hands? Who knows? Okay, majority. Good. Circuit breaking is something that prevents cascade failures in your application. For instance, if service A uses service B and service B is down, service A should not fail. So next big thing, Zipkin. Zipkin is a tracing tool, also was open sourced by Netflix. It's the thing that allows you to trace your calls between microservices. Basically, next thing, Ribbon, a client-side load balancer, Zool, gateway, and of course Spring Boot and Spring Cloud project. So, and that was pretty advanced technology stack in that time. We even went with it to production with one customer in 2015, and it was really pretty challenging and advanced. But time passes and everything changes. So if we jump to 2019, you will see a technology stack like this. It's completely different. You can mostly see that it is split to three categories. So first one on the left side of the screen are Kubernetes, Docker, and Helm. So Kubernetes is a de facto industry standard platform for hosting your microservices. Docker is de facto industry standard for building containers for Kubernetes. And Helm, it's not de facto industry standard, but it's getting very popular. A thing that allows you to easily deploy your microservices stack to Kubernetes. So it's kind of not orchestration, maybe even orchestration thing where you can describe the whole of your application as one help chart, run one command, and it will be deployed to your Kubernetes cluster. So next group of items that you can see here is Node.js, Python, Go logo, also Spring Boot, Spring Cloud, too much of that to put in one page. So that's representatives of languages, the most popular, using which microservices are built. So if microservices previously were mostly about Java because Netflix was Java, now microservices are using quite variety of languages. Basically, on top of that sits API orchestration. So there is an Open API initiative and Open API version 3.0 standard. There is a gazillion of tools that support it. Basically, the most popular one and free is Swagger, where you can describe your APIs, but there are a lot of others like API, RPG, and so on. Each API management platform that respects itself supports Open API standard. And the last but not least category is, I would say, a category of tools that are helping us to build good cloud-ready and like traceable and manageable microservices in 2019. So there are a lot of them actually. So you can see like Prometheus. It's a thing that allows you to gather metrics and have some insights on what's happening with your microservices. There are Jagger and Open Tracing. That's basically the successors of Zipkin. There is Istio. Next talk, by the way, will cover Istio a bit. So it's Service Mesh thing. It allows service orchestration, some logging security, etc., etc., etc. So there are some things like FlyND. So if earlier probably you heard about Elasticsearch Logstash Kibana stack, then now it's mostly Elasticsearch, Flying D Kibana, and tools like Sentinel, Resilience4j, and other not mentioned here is a count of circuit breakers for our microservice applications. So there are many more which are not listed here, but we just don't have time to cover it all, unfortunately. So I mentioned term cloud native. So what is it? It's not something, how to say that? Okay, cloud native is kind of approach how you build and run your application. So there are some main practices, main pillars of cloud native, which you have to follow to say that your application or your software suite is cloud native. So first thing is loosely coupled microservices. Second is lightweight containers. Third one is continuous delivery, zero downtime deployment, scalability, ability to scale up, scale down. It's all about horizontal scalability, not vertical one. And fourth one is automated infrastructure. So your typical Java cloud native application in 2019 will look like this. So Helm for describing the deployment, Kubernetes as runtime, Docker to package your container, Java, Spring Boot, and Spring Cloud, the default choice for your microservice application. And basically, when you deploy your application to Kubernetes cluster, it looks like this. A lot of squares, so let's take some time and let's look. So Helm, as I said, Helm is the thing that describes deployment and rollouts everything in your Kubernetes cloud. So Kubernetes is very big thing. On one hand, it's pretty complex. On the other one, if you master it, it's pretty easy, and it makes your life way easier with microservices, just because it can do ton of useful things for you. So let's briefly walk through what Kubernetes gives you. So first thing is jobs and cron jobs, basically periodical jobs that you can launch. Like there are lots of applications that need to run something periodically. Kubernetes allows you to configure that and run. Internal DNS for name resolution. It has monitoring subsystems, so-called liveness probes, readiness probes. It monitors your load and allows you to scale based on that. So it contains service mesh and gateway for orchestrating your microservices. It contains persistent volumes, the thing where you can actually store your data. Some security, especially in conjunction with service mesh. By the way, Kubernetes is designed to be a multi-tenant thing, so like your customers or vendors may have one big Kubernetes platform divided between teams with different projects, say everything hosted on separate namespaces. Of course, Kubernetes has logging. It has configs. For instance, such thing as config server in 2019 in microservice architecture is no longer needed. It was needed in 2014, 2015, but now all configs are in Kubernetes. Secrets, a kind of configs for sensitive information, passwords, TLS certificates, etc. Load balancing, pretty related to service mesh and gateway. There are other things not listed here. And there is one little tiny red square that is your application here. Well, that's truth. I'll explain why. Unfortunately, not everything is cloud native, and you cannot do everything with your Kubernetes cloud. So one big problem for now is database. There are a lot of attempts, a lot of charts for Helm to roll out a database into Kubernetes. But the reality is that very low number of databases are cloud native and can be safely run in Kubernetes. So in practice, most likely you will have the database either hosted on physical hardware or hosted as a service. For instance, on Azure you can have SQL Server as a service. On AWS you can have, how they call it? They have MariaDB running their service. Doesn't matter. Anyway, they have kind of PostgreSQL and service and so on. So database and service. Next thing that can be hosted in Kubernetes is actual physical storage volumes. These things, persistent volumes, are just links to physical storage. Of course, Kubernetes cluster monitoring is out of cluster, and user or internet availability for application monitoring should be also hosted outside of Kubernetes, because the reality is that sometimes there can be some last mile break where your application works perfectly fine in Kubernetes, and Kubernetes reports green light, but end users cannot reach it. So there are some tools like run scope, for instance, and services, by the way, that are designed to monitor your application availability. So basically like any modern cloud native application in 2019 will look like this. Kubernetes is not the only platform, but de facto it's industry standard. It's not becoming, it's already became. So, Kubernetes. 2 words about Kubernetes. As I said, it's already became an industry standard. There were some competitors for it, like there was a war between Docker Swarm and Kubernetes. Kubernetes won, obviously. For developing microservices, you will need either a Kubernetes cluster, which can be hosted virtually everywhere, like AWS, Azure, Google Cloud, Heroku, whatever. Only lazy cloud provider doesn't give you an opportunity to have a Kubernetes cluster. Or you can use, for instance, microkite.io to have a full-scale Kubernetes cluster running on your local environment. By the way, it's not a problem to start this thing here on a laptop. I actually tried that and it's run. So up to you, but you need Kubernetes to try to have the full picture of your Kubernetes application. As I said, there were a few competitors like Docker Swarm, Mesos. Don't waste your time on them now. Next building block is Docker. I believe that everybody is familiar with Docker. Docker is a kind of revolution, but it's not something very new. There were Linux containers before Docker. Docker just made it extremely user-friendly. It allows you to standardly package and ship all kind of applications. Like if you can run your application, you most likely should package it inside Docker container, and Kubernetes doesn't care what is inside. It just spins up a typical Docker container which has everything needed to run the application. So deliverables are, in microservice world, Docker images, not jars. Nobody plays with jars anymore. Of course, there are some third-party containers and third-party Helm charts that you can reuse to deploy to Kubernetes, and you should do it. Basically, there are some runner-ups, some competitors for Dockers, like Rocket, for instance, RKT, maybe you heard about that. They're not in trend still, so for now we can safely skip it. Maybe it will be a big thing for, I don't know, 2022. Let's see, let's wait. So next and final big thing for building a cloud native application is Spring Boot and Spring Cloud. Why? Because it builds an executable jar that is easy to package inside Docker container. Spring Cloud projects provides you with a set of components that allows you easily to have most of characteristics of microservices just in like 5 minutes by adding necessary Spring Boot starters. So basically, it has packaged client-side load balancers, Ribbon, for instance. It has packaged service discovery, for instance. If you are running on Kubernetes, you can add the project so-called Spring Cloud Kubernetes, and it will be doing service discovery based on Kubernetes APIs. Of course, some health checks are there, things that provide you health information, metrics, circuit breakers, tracing, authorization, and other like configs, and other things are needed. Okay, so microservices is not about Java. There are other languages and pre-built applications that can be run in Kubernetes as a part of your microservice suite. And unfortunately, they are not, they may be not cloud ready. And if they are not, things like service meshes, for instance, Istio, comes to the rescue. So Kubernetes by itself supports server-side load balancing. However, service meshes can do many more. For instance, routing, they can do security, they can do some tracing, monitoring, circuit breakers, a lot more. So if you are not running cloud-native microservice, you will have most likely to use something like this. If you are cloud-native, then it's pretty doubtful solution. And last big building block is Helm. So as I said, Helm is an ultimate thing to describe your microservice application, like as a completely deployable solution to Kubernetes cluster. It's kind of Docker registry for, let's say, Kubernetes. Like with Docker, you can pull some image and have it running on the environment that somebody pre-built for you. The same here, the same with Helm charts. Somebody builds charts, you just pull it, deploy to Kubernetes cluster, you run. So it's highly customizable, scriptable, etc., etc., etc. So basically, that's it. That's it about how microservice looks in 2019. So next part of the speech is about what to expect in 2020 and beyond. I have to give a warning that it's very subjective opinion. I can be totally wrong. I'll be a bit provocative here. It's intentional done. But still, let's go. Just to remind, by the way, there are no questions. Why nobody doesn't ask anything? Okay. Sorry. Can you repeat your question, please?
Okay, and what about such languages as PHP and Ruby? Can the apps developed on them be deployed to such infrastructure?
Absolutely. If you can run your PHP application or Ruby application in Docker container, then you can deploy it in Kubernetes, and you're good to go. Why not? Even before Kubernetes, we were building for one of customers one solution where everything was Java, but one service was PHP. So it is a bit of hacking, of course. We even managed to integrate this with Netflix Eureka, which is a service registry. So it works perfectly. There was one more question.
Yes, you haven't mentioned anything about like practical experience, which would be very useful because you have a lot of experience like error handling, message broking system when you communicate between different containers in Kubernetes.
Practical experience, yes, I am not sharing it just because we are limited with time. we have about 45 minutes here for a speech. So if you have any questions about practical experience, I'll gladly welcome you on coffee break, and I'll answer all your questions. Speaking about, well, my practical experience, as I mentioned, last 5 years I am building microservices, and most of those, on majority of projects, are on production. So it's like this. This all speech, this is based on practical experience. First part, second part, like 2014 part, 2019 part, and further thing also based on practical experience was selected.
Okay, my question is about how you would evaluate complexity of setting up Helm in a project. Do you need DevOps for this job, or any senior developer can do it? Thank you.
Okay, how would I evaluate setting up Helm in a project, and do we need DevOps for this? A good question, and the answer is it depends, and it depends mostly on the mindset of people that are working on your project. If they are pretty agile and eager to learn new things, so you don't need a DevOps. You don't need DevOps because Helm is pretty easy thing. You just install it, you configure a tiller on a Kubernetes cluster, and you are good to go. It's not that hard to learn a bit of Go templates. If you have like old-fashioned developers that believe that their and only their responsibility is Java, then probably you will need a DevOps. But frankly speaking, it's a problem, because Java developer or any developer cannot be writing just Java applications in 2019. Basically, everything goes full stack, and ideally, if you want to have a good value on the market, and if you want to bring a lot of value to your customer or your companies that you are working for, you need to understand the landscape, and you need to be able to like do everything, starting from Kubernetes and from DevOps work, ending with front-end, ideally. Of course, you don't have to be like a master in everything, but you have to be smart enough to be able to understand and use it. Last question. By the way, speaking about like my work, for last year and a half, I actively started to learn Kubernetes, and if you are speaking about my like technical part of work, I would say 40% is DevOps work, despite the fact that I am not Linux guru. I am running Windows at home, like in my development PC. Like 40% of my time I spent with cloud, like Linux and the work. Another 60% like Java, and a bit of front end. Very tiny piece. Okay.
Is there advantages for using microservices for a very small application or middle scale?
If you don't mind, let's discuss this on coffee break. Okay? Okay, so no more questions. Let's continue. So landscape 2019 plus. It's how your typical best of breed cloud native microservice application looks today. So what can change? How do you think? Why not? Yes, we can do it. Serverless is a bit another thing. Spring Boot will most likely not completely removed. We'll speak about Spring Boot a bit later. But what else can change? I don't think so. Splitting everything in even more, making one big container is not a good thing. Any other opinions? What can change? No? Sorry, what Java out of the box will support? Java is not going there. Okay, as I said, I'll be a bit provocative. So what if you remove Java? But it will be still a Java microservice. How can that be? Okay, what is ELF? That thingy. Basically, it's Linux executable file to be exact executable and tunkable format, treated as Linux binary. So the thing is that there is very, I would say, titanic effort going on from Oracle, and a lot of already new things, new frameworks supported. This effort is called GraalVM. Anybody heard about it? Yep. About 10 people, 40, good. Good. So GraalVM is was, it's already right to say was, a research project from Oracle. As I said, first stable release was done in May. So basically, GraalVM is a multi-language polyglot VM that allows you to run various languages, not only Java, but JavaScript, Python, R, whatever. In the same time, you can mix it in one application. It supports ahead-of-time compilation. And basically, with ahead-of-time compilation, it can produce executable files. And we'll speak a bit later why it is important. Of course, there are some limitations, also a bit later about this. And, well, that's it, few words. So, on the timeline, you saw Micronaut, right? So, in order to run on the next generation virtual machine, we need something that is next generation framework, right? And so far there are two of them pretty popular. Micronaut is already on technology radar. Quarkus, it's still kind of new thing. It's 0.17 version. The common thing of these two frameworks is that they are both capable to run on traditional hotspot and GraalVM. They are cloud ready, they have small memory footprint, they have rich ecosystems of modules. So basically, as you have in Spring Boot, you have Spring Boot starters, and both Micronaut and Quarkus have a set of kind of starters modules which you can plug in and have the same functionality like in Spring Boot. So if there is some popular technology, for instance, Hibernate, there is a plugin for Hibernate, there is a plugin for Kubernetes, there is a plugin for circuit breaking, a plugin for everything what you need. They both support imperative and interactive programming, so like, that's it. So, why I'm stressing here in attention on small memory footprint and then being next gen framework, it's because typically microservice application scales. Typically, microservice application runs on Kubernetes, where there are a lot of other microservices being run. And you know that Kubernetes has a kind of approach where there are some physical pods that are executing your code, and all of the applications are competing for resources. So a bit of benchmarks. A bit of benchmarks comes next. So, as I said, two big things here. CPU utilization, well, let's say about startup time, and memory heap usage. So, startup times. Pretty interesting, right? And it's not a mistake. So basically, Spring, as of today, doesn't run out of the box on GraalVM. It can, with some list of hacks, list of tunings. It cannot run fully because of GraalVM limitations. There are some limitations with reflection, some limitations with dynamic proxies. For instance, GraalVM doesn't support dynamic class loading at all. Forget about class loading in runtime with GraalVM. It's done because of all that native thingy, optimizations, and so on. But still, a bit of figures. So here are three main runtimes tested. The black one is what happens when you just click debug on my Windows 10 laptop and you run it from IntelliJ IDEA. The second one is when you run it via hotspot VM on the Windows subsystem for Linux, basically kind of Wine for Linux right now. Wine for Linux, which runs Linux on Windows. And third one, the smallest one here, it's GraalVM native compiled image run on Windows subsystem for Linux. So, and as you can see, Quarkus starts in 100th of a second. That's not a joke. If you have some time, I can show you. Micronaut is slower. It's like 18 times slower, but still it's Titanic comparing to Spring, which takes in its regular shape 3 seconds to start. And even if you run on just hotspot without compiling it to native, it's Java 8, we run like Quarkus outperforms Spring like more than 4 times. Okay, so that's about startup times. Okay, there's a question.
But GraalVM does have license, no? And you need to pay if you want to use it with updates.
There is community edition, there is enterprise edition.
But the community edition without updates. And if you want to have some updates, you need to pay like extra money. It's like, as I remember, we had some presentation in Lviv from developer from Oracle with GraalVM. No?
Okay, it's an interesting question.
We had the presentation from Java Lviv community, and we had some developer from Switzerland, as I remember, and he said that if you want to have some support from Enterprise Edition, you need to pay money. You also can use Community Edition, but for Enterprise Edition and with support with updates, you need to pay extra money.
Okay, I'll answer your question in the following way. Probably you know that Java, regular Java, has enterprise support, right? Long-term support, which goes way beyond public releases. So even if Java 8 is considered like end of life, if you pay money, you have long-time support. So, 40 people in this room, can you please raise your hand who runs on paid Java? Who pays for Java? You're a liar. Did I answer your question? So for those on YouTube, it was 0. So basically, my opinion, I cannot say that it is like a fact, but my opinion is that the situation will be pretty similar. So majority of people will be running Community Edition. Okay, if there are no more questions regarding CPUs and regarding Graal, let's speak a bit about heap utilization. Heap utilization just for started application. By the way, versions of all the software is slightly stable as of Wednesday, when I checked. So it's Spring Boot 2.16, Micronaut 1.1.3, if I am not mistaken, and Quarkus 0.17. So if you, as you can see, the heap utilization of Quarkus is also pretty low. It's just 2.1 meg. Applications that are being tested are simple, very simple applications that just return some data via REST. So nothing fancy there, but native compiled binary of Quarkus is almost eight times less than Spring Runtime. 8 or 7, doesn't matter that much. So basically, these fast startup times, of course, lower CPU usage and lower heap usage comes as a benefit to you and to your vendor. For instance, you can drastically save on infrastructure. You can have less hardware running the same amount of services. So, as I said, it does come in with some price. First of all, you cannot run Spring right now. I must say that some effort is going on Spring Boot 2.2 and higher versions to make it run on Graal VM. Some parts already can, some part cannot. But there are optimizations going on heavily in Spring, but still it's not there. It's not there. Maybe it will be, maybe will not, but at least Micronaut and Quarkus pushed Spring and pushed industry for going something more lightweight. So in order to run Spring on Graal VM, you need to get rid of some things that are basically fundamental principles of Springs. For instance, dynamic class loader. Dynamic class loading, Spring generates lots of proxies. It does it either using Java proxies or either using Aspect-J proxies. It does some bytecode engineering, and all of that should go away, at least in runtime. In compile time it could be done, but in runtime it's completely forbidden. So forget about that. Reflection and proxies are also pretty interesting in Graal VM because compiler tries to identify what exactly method will be called by reflection, for instance, and it tries to replace reflection by real code executions and so on, so on, so on. We are not going deeply into Graal VM, but still, just some fundamental limitations to mention. So, as you know, Spring heavily relies on this. There are other limitations. There are bugs on Graal VM side. There are even pretty interesting defects or bugs when you were getting, let's say, different code results when running the same code with Graal VM and Hotspot. And all of this is being sorted out. So basically that's everything that I wanted to say you in the scope of presentation. Fortunately, we don't have time for demos. I would gladly show you launching some native images, but not today. So thank you for your attention, and maybe you have some questions to ask. Some few last.
On the last slide, you write that dynamic class loading not supported in
Graal VM.
Graal VM. Does it mean that JRebel will not work with it?
JRebel, JMix, Java Debugger, and another things. Java Debugger is not working on Graal right now.
Okay.
If you run your application as Graal, there is some beta or some, I would say, not production-ready effort to replace C2 compiler with Graal VM in Hotspot. But basically, if you run your application, if you compile the application to native, no Java debugger. Forget about it. But you can use some Linux debugging tools for native images.
Thanks.
There is one more question.
Do you or your team have any successful experience deploying Micronaut-based service to production?
No, unfortunately not. My experience in Spring-based. However, there are a lot of other people running Micronaut on production. By the way, Graal is used on production by Twitter for a long time already.
I heard about that. Thanks.
Certainly nice to have speed up times, yeah. What are actually like code bloat? Did you measure it? Like code bloating into native binary for your microservices? Like code size, how much it doubles, triples, and so on. And I'd like to ask you, isn't just more important to choose fine garbage collector, yeah, like Shenandoah? So without the stop the world, isn't there much more benefit that we get with Graal with just faster load? You know, like, is it actually so important to have such fast loading than for your application? Like, what's the actual benefit? And what can you say that Graal VM Community Edition actually is missing important compile optimizations? Like, it's I would say it's crucial, you know, like to have the top performance. And don't you think like ahead of time compilator can actually optimize with hot loading time, you know, like all the parts of code?
Can I ask you to make a little pause here, and let's answer, answering your questions one by one.
Sorry for long.
Okay, because I already forgot what was the first one. Okay, so if I remember correctly, the first one was about binary sizes, right?
Yeah.
So let me just quickly check if I have those binaries compiled here. If not, I'll launch the compilation. So what do you want to check, Micronaut or Quarkus?
Okay, let's Micronaut.
Micronaut, okay. Okay, Micronaut. If I have the native image, I have the native image here, but I don't have the jar compiled. Okay, let me quickly rebuild it. While it's building, it takes some time. While it's building, I'll answer your another questions. So maybe let me move this thingy here. So we just packaged the Micronaut application, and where's my terminal? Where's my terminal? Well, you already can see that Micronaut native application. Yeah, I have it here. So, original jar of application. By the way, just to test. Yeah, it's run. It's run. My laptop is in power saver, but still. Original jar of Micronaut is about 12 megs, and the binary, the Linux binary size itself is 53 here. That was first part. Oh, sorry. Here my console is listing. Okay. By the way, also in power saver, let me move it to best performance, and just a bit of compiling. So it's quite heavy process, just for you to show. So will be compile the Micronaut application in Docker, where Graal VM is. So sh docker, let it build. Let it build. Okay, while it is building, your second question was?
Yeah, my second question was actually, what's the real benefit from super fast speed ups when you're missing important ahead of time optimizations, and isn't of more importance using garbage collector without the pause the world, you know, like for production, than actually using, I mean, it's nice certainly for let's say application for desktop, it's certainly nice to have fast, you know, launch time, yeah, but is it that important for actually server application, or it's more important to fail fast and reload, like for this kind of architecture? Like,
okay, one story from my experience. As I said, I am running microservices on production. I had a pretty interesting case where my application on local computer was starting about 15 seconds, typical Spring Boot application. But when it was running on Kubernetes with some limits implied by administrators, its startup time was about 2 minutes. Because of other applications running on same Kubernetes cluster, because of competition and so on. So basically we had like liveness props configured for 1 minute, because it can start on my hardware like in 15 seconds, why it shouldn't start in 1 minute. And our application on production, unfortunately, once went into endless restarts, just because Kubernetes was killing it. Oh, what's happened? It's still compiling native application. So Kubernetes was killing it because it was thinking that it hangs on startup and restarting. So that's why it's important. The same answer is for heap. You can run more applications in the same size of cluster.
have you tried maybe OpenJDK 9? They have pretty nice feature with class cache, you know, like they cache the class loader, and maybe you had some
mean class data sharing?
Yeah.
Class data sharing is there from Java 6, if I'm not
they
mistaken.
improved it a lot.
No, I wouldn't say here much. Unfortunately, didn't try that. I remember you were asking about next-gen garbage collector.
Yeah.
So, garbage collectors, garbage collection is pretty interesting thing. In my experience, I had an experience of running and building actually a few massive multiplayer online role-playing game servers, kind of World of Warcraft and others. We were running, of course, Java, and we were running Java 6. We were having issues with Stop the World unless we followed two practices. It failed. Just a second. It's a shame. Let me quickly fix it. So anyway, we were running massive multiplayer online role-playing games, and two practices came to our rescue. So first practice was do not create objects, or create as little objects as possible. This included removal of calls for iterator for array list, for instance, because iterators were some short living objects, and your heap was like going terribly up, going terribly down, up, down, up, down, and so on. Okay, so let me try one more time. Now, what it has: endpoint, error, userland, proxy, port. Now, I will not copy it. Maybe Docker stars will help, but still, it always happens on presentations. Okay, basically, the idea is that building Graal application takes pretty much time. So, second practice was to enable pretty old conch-mark and zip garbage collector. Just those two practices, and we had no troubles. We had about a few thousand players live with amount about 50,000 say NPCs. So all of that was running on the single JVM. So no problems with stop the world here. So maybe Shibboleth and G1, GC are better for something more high load. But frankly speaking, I imagine quite hardly the system that can have such a big issue with stop the world.
Yeah, and you can heavy use, LRU caches, and they just don't follow the hypothesis of the generation, like they're actually inverted.
Okay. If you don't mind, I'll kindly be ending my speech just because I am already over my time limit. A last attempt to do everything right. Okay, so it worked. A last attempt. I have now my freshly compiled Micronote binary, copied just a few minutes ago. And yes, it's for Micronote, it's 4.5 times bigger than one jar. But who cares? Hard drives are cheap. Okay. So, maybe one last question from another guy. If not,
thanks for your answers.
The last one question. You, as sort of solution architect and tech lead in your company, do you have any plans to propose for your customers to use Graal VM or Micronaut in their future solutions?
Not today. Maybe.
Are you waiting for something?
I am waiting for wide adoption.
Okay.
The thing is that it heavily depends on customer. Some customers are okay to run bleeding edge technologies. Other customers are more conservatives. So current my customer is quite conservative company, and frankly speaking, they still don't use some techniques and best tools. For instance, in front end, they still don't use create React app from Facebook, which is de facto Spring Boot in React world. They still do it manually, and you need to go through lots of circles of those bureaucracy to convince them. Other customers, like the one for which I worked 3 years ago, was kind of startup company, about 100 people, and it was pretty easy. You just had to convince the CTO. So there, with that company, we went in 2014 with Microservices.
Okay, thanks.
Okay, so I have one little prize for questions. This neat umbrella. And this umbrella goes to the person who asked the most count and the most challenging questions. So here you go. Thank you. And I think we have 10 minutes break, and the next speech from Sergey.
Let's get started. Hello, everyone. We had some technical issues. Sorry for that. How many of you works with the microservices? A few people. Okay. So we are going to talk about microservices because everybody wants to work with microservices if you don't already. But it's not so simple. So that's what we are going to talk about. Just a minute. I have to change something. Okay, not the right screen, I guess. All right. Okay. Okay, I should switch the displays. Yeah, now it's okay. Okay, so my name is Sergey. I work at Logica. Also, I'm a member of program committee at Morning at Logica community, if you know this community. If not, then Google it. So what we are going to talk about. First of all, we are going to talk about what Service Mesh is and why should we care about it. We are going to talk about the most popular implementation of it, which is Istio. I'm pretty sure that most of you heard about it. Oleg also mentioned it. There will be a quick demo and a summary. First question is, why microservices? Why everybody wants to build microservices? Everybody wants to work with microservices. Of course, because it's a trend. So nobody wants to be working with monolith. Everybody wants to be in trend. So that's why. Of course, I'm joking because there is a lot of pros of microservices, one of which is faster time to production. So with microservices architecture, we can release every day, a few times a day. With monolith, it's much harder because you have to change all the application, you have to test the application, so it takes a lot of time. Also, it makes changes less expensive because if you need to change some feature, you don't have to change everything. You change just one microservice, you deploy it, everything works, everybody is happy. It allows you to use the right tool for the right job. So you are not, you shouldn't be stick to one technology, to one framework, even to one language. You can choose everything you want. And many other pros of microservices, but we are not going to talk about it because we are going to talk about the complexity that it brings to our architecture. Because if you have a monolith, you have one instance that you have to manage, you shouldn't care about the infrastructure. With microservices, it's much more complex. What do I mean? So we developed our business logic, we developed our microservices topology, and we are ready to go to production. Of course not, because then we realized that we have a lot of infrastructure stuff that we have to deal with, like logging, like metrics, like service discovery, and so on. How do we solve it? The most common approach is using client library. So we have a client library for service discovery. We build it into our microservice for circuit breaker, for metrics tracing, and so on. And we use it in each of our microservice. And it works fine. Everybody knows how it looks like. Who works with microservices and do not use Spring? Spring Cloud, I mean. So looks like everybody does it. But we have a problem. What if we want to build a polyglot architecture? For example, maybe we have some service which is high load, and we want to use Go because the concurrency model in Go is quite nice, simple. Maybe we have a microservices that has some machine learning, and then of course we have to use Python. Then we can, if we build these libraries by ourselves, we can duplicate the code, but then we need more developers, more time to test it, and it takes like more time to go to production. It's not why we choose microservices. Or if we choose some libraries that are already built and open sourced, like Spring. We can choose some analog on other technologies, but then again, maybe this library uses a different protocols for the same thing, and we have to test that it works fine. Maybe it uses the same protocol but different versions, and again we have to test it. And again, we have to spend more time before we go to production. And that's not why we build microservices. To overcome this problem, there is a sidecar pattern. What this pattern is all about. With each microservice, we have a proxy that includes all of this infrastructure stuff in it. And the microservices talks not to each other directly, but through this proxy. And now we can use this proxy for each of our microservices, and we can choose any technology, any framework, whatever we want. But then we have a problem with configuring this proxy, because nobody wants to configure each proxy one by one individually. There is next abstraction over the sidecar pattern, which is called Service Mesh. We have a new instance. It's control plane. And we configure the control plane. We tell control plane, hey, I want my microservice cluster to be in this state. And the control plane makes sure that it's configured and it's in the desired state, the state that we wanted. Who heard about a company named ThoughtWorks? Oleg also mentioned it already. 1, 2 persons? All right. I guess all of you heard of such people as Martin Fowler, Neil Ford, right? Maybe somebody read the books from these guys. If you didn't, you should. This company, they usually do consulting. And twice a year, they present such stuff, which is called ThoughtWorks Technology Radar. And Service Mesh, even though it's a young concept, it's already in this technology radar. What this radar is all about. So it's a set of technologies, of practices, of languages, and so on, that they consider most popular and the best on the market. And Service Mesh is already in this radar, in the category trial. Trial means that you should consider it definitely if you have this problem. So it's not in adopt. Adopt means use it everywhere. Trial means if you have this problem, use it. And the most popular implementation of Service Mesh is Istio. It's open source. It's written in Go. What's the main component of Istio? First of all, it's control plane, which we talked about. And it contains 3 main components. There are other components, but these 3 are the main components. It's pilot, which is responsible for configuration of our proxies. It's a mixer, which is responsible for collecting telemetry like metrics, logging, tracing, and for policy checks. And it's Citadel, which is responsible for security inside of our cluster. And the proxy, this is Envoy. Envoy, it's something like Nginx HA proxy, which all of us heard about but now it gains a lot of popularity because it's very performant and very configurable. It's built at a company named Lyft. It's like Uber, but Lyft. And that's how our architecture looks with Istio. So it's the same, but we have like proxy our Envoy. And of course, Istio works better with Kubernetes, even though they say that it supports other environment. But if you choose to use Istio with other environments, good luck with that, because you will have to have a lot of problem. So if you use Kubernetes, you can use Istio out of the box. And of course, Istio also got into the ThoughtWorks Technology Radar, also in the trial category. What problem does Istio solve? So let's go to first, it's service-to-service communication. What could possibly go wrong? So like we have services, they talk to each other, everything's okay. But we have a lot of instances and they sometimes will fail. Be sure that they will. And we may have some auto-scaling or auto-healing mechanism that will bring up new instances. And of course, we don't want our instances that failed to be called, and we want to call the new instances. For this, we have service discovery pattern. we have a new instance called service registry. Each microservice registers itself to this service registry. And then when service A wants to talk to service B, it calls service registry and tell like, hey, give me the address of service B. It got it, make a call, and so on. And this is where Istio connects. So we require to use Istio, a service discovery mechanism that already works. And Kubernetes give us this stuff. It uses DNS. Okay, so the next problem is fault handling. Even though we managed to deal with service discovery, the main problem is a lot of people relies on network. The network is not reliable. You should to know that. What do I mean? When service A calls service B, the truth is that we never know if this call even goes to service B. In the worst case scenario, we will wait forever. Of course, we don't want to wait forever because the workday is over and want to go home and stuff. And that's why we have to set timeout. If this is a really important call, or we just want to make sure that this call will go to service B, we have to set retry. And Istio has a feature, Istio resiliency, when we can set these timeouts and retries. And moreover, we can set these timeouts and retry for different requests. For example, if users are using a web browser, we can set timeout 1 minute and 5 retries. If this is some sort of mobile devices, we can set timeout 15 seconds and 3 retries. Sometimes the service is okay, it seems okay, like the process is running, but it's not so healthy. So user makes a call, wait a lot of time, and then it got error. And all the users that make the call, they wait too long to get error. Nobody wants to get error in the first place, but sometimes we have to deal with that. But nobody wants to wait a long time for errors. To overcome this, we have circuit breaker mechanism. Oleg also mentioned it. And Istio has this circuit breaker. It's a basic circuit breaker, and we can set up this using maximum connection, maximum pending connection requests, maximum request, and consecutive errors. So it looks like we more or less solve most of the microservices problem. And now, as all of us are good engineers, we have to test it. What's the difference in testing microservices and monolith? With microservices, we can have a scenario when one service fails, and all the services that calls this microservice will cascadingly fail. To test this, we have to reproduce this scenario somehow in our test environment. Who heard about house engineering? Anyone? Who heard about Netflix? Okay, everybody heard about Netflix. So they introduced this house engineering. They built a tool which is called House Monkey. This is the tool that goes to production and kill instances in the production. Of course, if you are not Netflix, don't do this in production. But in some test environment or pre-prod environment, we can use Istio to inject some faults in our services or to inject some delays in our services and to emulate some failures or emulate some network delays, network latency, and so on. After we test this, we are ready to go to release. What are the main mechanisms to release microservices? One popular mechanism is called blue-green deployment. So we have service 1, version 1, which is in production. User can see it. We deployed service version 2. User cannot see it yet. We marked one of it as blue, another as green. In this case, it's green is service version 1. Service version 2 is blue. We run all our tests on service version 2, and when we are sure that it's working, we can switch traffic. So we have 0 downtime. Users start to use version 2. Everybody's happy. But sometimes our test cannot reproduce all the stuff that is going on production. So Istio have traffic mirroring when user still uses version 1. But Istio will mirror all the traffic to service version 2. So user won't notice that they are sending requests to version 2 because they're getting response from version 1. And we can still see how our new version of service will behave on the production traffic. One more mechanism to release, it's a Canary deployment. We also have version 1 and version 2. User uses version 1. we mark version 2 as a canary. Why is it called so, first of all? It goes from the coal miners. So coal miners, they have like a lot of risk because like they work deep underground. And besides being deep underground, which is not a usual environment for people, there are some possibilities of toxic gases. And most of these toxic gases doesn't smell. And they notice that if they bring a bird called canary with them, these birds die pretty quickly if there are some toxic gases. And then it means that they should get out of mine. So like canary tests the new environment for them. This is the same concept. We send some small % of traffic to the new version of the service. So this is our birds that will notice some bugs, something is going wrong. And we can have quick feedback from the users. And also, if something goes wrong, we can switch back like traffic to version 1. And in the worst case scenario, we will lose at most 1% of the users, which is much better than losing all the users. Istio can perform this using a feature called advanced routing. And moreover, we can redirect some particular users to the new version, like mobile users, maybe our test users inside our organization, and so on. The next important thing in the microservices architecture is security. This is the thing nobody wants to deal with. How the typical security looks in the microservices architecture. We have HTTPS request, which goes inside our cluster, then we have TLS termination, and all the traffic inside our microservices is not encrypted. Why? Because to encrypt the traffic, you have to provide a pair of key and certificate to each instance of our microservices. We have to have some certificate authority, and all the instances of our microservices should know how to talk to this certificate authority. This is a lot of things to do, and only after that we can have encrypted environment. So maybe it's too much work for having encrypted traffic inside our microservices. But with the Istio, you already have Istio Citadel component. You already have proxies that knows how to talk to this Istio Citadel component. And Istio Citadel can generate and provide the key and certificates to each of these proxies. And we can just say Istio, hey, encrypt my traffic, and all the traffic is encrypted. Just one configuration. Okay, so we are in production. Everything works fine until some moment when users say that I'm getting an error, or I'm waiting too long for my request. How can we know where something goes wrong? Because in monolith, it's obvious. It's in your monolith. In microservices, it's somewhere in some service. To overcome this, Istio have a component which is called Istio Mixer. And the Envoy proxy is already sending a lot of information to this Istio Mixer. It's like tracing its metrics, its logging, and all other stuff. Then Istio Mixer, through the adapters, can send this information to different tools. On the market now, there's a lot of tools for your needs. So if you run on Amazon, you can use CloudWatch. If you run on Google, you can use StackDriver. This is not the full list of adapters already available in Istio. Besides that, you can build your own adapter for your own tool if you still don't have it. Okay, let's look at the main components of Istio. So we have our Kubernetes cluster with our services in it. First of all, we have to allow traffic to go inside our inside our cluster. For that, we can use gateway. Then we can use destination rule to mark our traffic somehow. For example, to mark version 1, version 2. Then we have virtual services to somehow use our traffic, like to mirror it somewhere, to route it somewhere. To go outside our traffic, we can use the same gateway or service entry. And also there are policies that we can apply to our cluster in general. Okay, so it's demo time. So we developed the new version of microservice, and we are ready to go to production. But of course, before going to production, we have to make sure that it's tested. Here I have a Kubernetes cluster deployed. So you can scan it or go to java.istiodemo.xyz. Okay. Still see some fonts. Okay, I'll wait 5 more seconds. And still you can go to java.istiodemo.xyz. Okay, I will show you how this application looks like. Not like this. Okay, so we have, you cannot see it. Something goes wrong. Okay, maybe someone can take a look at it. Yeah, please, but wait for the microphone.
Yes, my question is about, like, you talked about green, blue deployment and so on. What if, for example, like our response body will change, or endpoint will be removed? How we can, if Istio gives us such a mechanism to, like for example, not to pass the traffic from one endpoint, like it should be, like, for example, our new version of front end will require that new API, so it will manage which endpoints goes on different green or blue.
Yeah, so there is one rule that you have to consider when building microservices. Don't do destructive changes. So for example, if you have to remove some field, so not remove, but rename some field. You have to add the second field. So in the new version, you will have 2 fields. It will duplicate. But you make sure that the services that uses the old API will still work. Because if you do destructive changes, it means that you cannot deploy the microservices independently. And that's not microservice architecture anymore. It's like some sort of microservice. So you have to do step by step. You have to add a new field. Then when all the clients that uses it move to the new field, then you can remove the old field. So this is one of the rule when working with microservices.
Okay, and the second question, how often do you use GraphQL instead of usual HTTP clients, RESTful services?
Do you mean if I use GraphQL?
Have you used GraphQL on Java?
Not in production. So like, I was playing with GraphQL a bit, but I wasn't using it in production. So
okay,
usually
thanks.
it's REST. Okay, so this is the application. We have our UI. This is our first service. We have then 2 more services. First one is quote service, where you get some random quote from Star Wars, some character of Star Wars. And the second is a Death Star service. It destroys one random planet in the galaxy of Star Wars. So when we click refresh, we get a new quote of the day, and we destroy a new planet. Okay. Yeah, I guess I can. Okay. That's better. Okay, so let's refresh it. We destroy the new planet. We get a new quote. But then somebody decided that this is kind of boring application, so we have to make it more interactive or something, and we decided to add images. So we have deployed, we have already built this new service, new version of the service. We can deploy it. Let's deploy it. Just a minute. Of course, it's a Kubernetes cluster, because I said that Istio works better with Kubernetes. Okay, Star Wars version 2. Let's wait while it's, oops. Okay, it's running. now if we refresh, we can see that sometimes we get images, sometimes we don't get images. That's because we just deployed this application, and the traffic goes load balancing between two versions of our services. But the second version is not ready yet because we haven't tested yet, so we cannot make sure that it will perform well in production. So we want to make sure that users don't get the version 2. Kubernetes can do it. Let's see how Kubernetes can do it. Okay. Let's do it with the quad service. All right. We can say that we want a selector that will route all the traffic to version 1.0. Okay, just a minute. Okay, of course I'm kidding. I know how to exit Win. All right, we edited. Now if we refresh, we don't see version 2 of our application anymore for the quad service. We always get version 1. We can do the same with the star service. But basically that's it when we talk about Kubernetes, what Kubernetes can give us. Let's do the same with Istio. First of all, we have to say Istio to inject our proxies to our services. For this, we can label our namespace where our service is deployed and set the label Istio injection enabled. All right, so we set the label, and now we can redeploy our application. Sorry. Okay, don't do this in production. You have to make like rollout deployment. But since it's just a demo, I will delete everything and we'll redeploy. And now, if we are going to watch at our services, at our pods in Kubernetes, we will see that we have state ready, and there is 2 out of 2. That's because now we have our services and our proxy injected into our services. Okay, I should actually have. Okay, I just deployed version 1. Just a minute, I should have one more service deployed. Okay, so we see that there is 2 out of 2 for all of our services. So it means that we have our service, which you just saw, and you have a proxy deployed nearby our services. Let's wait when everything is ready and running. All right, one more. Okay, looks like everything's working. Let's see. Okay, so we have again 2 versions of each service. It gets load balanced between that. So we want to do the same stuff that we did before with Kubernetes. I mean, just to show the user only version 1. For that, we have to apply a few configurations. First of all, it's destination rules. Destination rules will mark our traffic. So we will say that we have 2 versions of our service. It's, for example, for quad service, we have version 1. It will match it by label version 1.0 and version 2. Let's apply it. Okay, all version 1. Oh, I applied the wrong one. Just a minute. Destination rules. Okay, so I have already applied our virtual service, because we also need virtual service that will say that we have to route all of our traffic to version 1. So this is a Kubernetes configuration. It's a Istio object, but this is a Kubernetes configuration. Okay, so I have already applied this virtual service, and now if we click refresh, we will see only version 1. So how cool is that? We'll like run a bunch of other stuff. We applied a bunch of configuration, and we get the same thing that we can get with the Kubernetes. It's cool, right? Of course not, because Istio, beside of this, can do all other thing. The first one is traffic mirroring. So for now, all the requests go to version 1. To make sure that it's true, and I'm not lying, we can see the logs of that star service version 2. That star service. Okay, so we click refresh, and we see in the logs that no requests come to version 2. But we can mirror traffic to version 2 as well. So for that, we have to set this section, which tells the same, like route all the traffic to version 1, but also mirror this traffic to version 2. So let's apply that. kubectl, apply, and traffic mirroring. Okay, we have applied that. Let's switch back to log. And now you see somebody is clicking refresh, and we got our request to version 2, but still on the UI, user cannot see version 2. We got only version 1. We can see how version 2 performs on the production traffic, but still user cannot see it, so we are not affecting our users. Okay, let's do something more advanced, like Canary Deployment. We can use our Canary Deployment on all the users that uses Google Chrome browser. So we also have virtual service. Basically, for everything that you will do with Istio, you will have virtual service. Here we say that when we match the header user agent that matches this regex, in this case, if the word Chrome is present in the user agent, then route this traffic to version 2. All other traffic route to version 1. Okay. kubectl, apply. Request routing from version 2. Now in Google Chrome, so I'm the user of Google Chrome, I can see version 1. In your mobile browsers, you will still see version 1. Or if I try to use, are you using Google Chrome? Okay, but you know, you have to make more advanced matching. So let's use Safari. In Safari, it's version 1. Oops, somehow it's okay. So still version 1. Okay, it performs not so good in Safari, but you can see the point. So Google Chrome version 2, Safari version 1. Let's try to break our application. Let's try to break our quote service. For that, let's inject a fault into our quote service. So we have the same virtual service that will send all our requests to version 2. And we will inject fault of type abort that will return us HTTP status 500 in 100% of the cases. So let's inject that. Fault injection, error quote. All right. We applied it. Now click refresh, and it's broken. So we can see how our application will perform when something is wrong with quote service. Let's break it even more. So for that, I will show you how the topology of my services looks like. So it's like that. We have UI service. It makes calls to quote service and that star service. Both of these services have two versions, version 1 and version 2. Version 2 makes call to image service, which returns us image. So let's inject a delay to this image service. Again, one more virtual service that will inject fault of type delay with fixed delay 7 seconds. All right, kubectl, apply, fault injection delay image. Okay, let's make a request, and we can see that we are waiting for 7 seconds for our that star service, and after 7 seconds we got the response. Let's do it once again. Now let's try to play a little bit with the timeouts, with the resiliency of our application. So for example, we want for our mobile users to fail after 5 seconds. Again, we have to apply a virtual service, request timeout. When we do the same, match by headers, user agent, if it matches iPad, Android, or iPhone, then we have to set timeout 5 seconds. For all the other requests, we don't have any timeout. All right, kubectl as usual. And request timeout. It's applied. Let's click refresh. Nothing is changed for the web browser. I should still get the request. But if you, from your mobile devices, or I will emulate the mobile device, we'll click refresh. Just a minute. Let's refresh it. Okay, it's somehow slow. Okay, we will see. And then after 5 seconds, I will get the upstream request timeout. So it fails before our response from the dead star service is back. Okay, let's remove this. kubectl delete Istio request fault injection delay. Oh, sorry, it should be. Okay, and let's apply the rule that will route all the traffic to version 2. Request routing version 2. Okay, so we don't have any errors injected here. So now all the users can see our version 2. Let's see what else Istio can give us from the point of observability. First of all, it's metrics. So out of the box, Istio supports Prometheus. So we have here a bunch of metrics that are already sent to Prometheus, like Istio request total, for instance. So it's the total amount of requests that were in our cluster. But of course, nobody wants to read the metrics like that, especially on this screen when you cannot see anything. That's why Istio also supports Grafana. And out of the box, you can use Grafana with a bunch of predefined dashboards. So let's see, for instance, how our Dead Star service performs version 2 of it. So we can see that we already have a bunch of metrics collected to Grafana, a bunch of dashboards, and we just can observe it. Beside that, distributed tracing. Istio supports Zipkin and Jaeger out of the box. In this case, I have deployed Jaeger here, and I can see, for instance, all the traces. You can see, like this. You can see all the spans, all the traces. The only thing that you have to do to support distributed tracing is to forward header in your application, because Istio cannot know which request that goes inside of your service respond to the request that goes outside of it. So you have to forward headers. That's basically everything that your application has to know about Istio. Okay, I said, yeah, please, question.
A question. So you said that Istio needs to know just a header. What about insights? For instance, Jaeger and Zipkin can show you up to method level traces, like which method uses how many time. I guess Istio cannot do that, right? It just shows a service as a black box.
For this one, you have to forward all the information to the envoy and then set up the envoy. Yeah, out of the box, Istio cannot do it, but it's possible to configure this. In this case, your application will have to know about Jaeger. So yeah, of course. Okay, so also I said that it's possible to configure the security inside of your cluster just with one configuration. Let's see what this configuration is. First of all, let's break our cluster and say that we want a policy that only will allow the encrypted traffic inside of our application. Okay, so kubectl, not annotate, apply. Okay, MTLS strict. The policy is applied a bit longer than our configuration, so let's wait a few seconds and then we will see that everything is broken. Alright, I guess the internet is a bit slow. Alright, let's open in another tab. Yeah, that's what I'm pressing. Oh, yeah, okay, so it's loaded, but you can see that everything is broken now because our traffic is not encrypted. And we said Istio to allow only encrypted traffic. If you remember, first thing that we applied was this destination rule. So you see how it looks like, it has subsets, that's it. Now we have to change it and add to our destination rule this section, traffic policy, TLS, mod, Istio mutual. That's everything that we have to do to encrypt the traffic inside of our cluster. Let's apply that. kubectl apply -f destination rule MTLS. Now everything is working. So you see the traffic is encrypted. You believe me, right? Who doesn't believe me? Really? Everybody does? Okay, you shouldn't, because I can show it on Grafana. So let's click refresh to make some traffic. Let's wait for Grafana. Okay. So now in Grafana we can see that we have a new type of requests with this lock here and MTLS. And we can see that all the new requests are with MTLS and no new requests without MTLS. So now all our traffic is encrypted inside of our cluster, just with one configuration. You don't have to configure anything else. Okay, about the metrics. So you have a bunch of metrics already sent to Prometheus, but sometimes we need some more advanced metrics. For this, you also can configure some custom metrics. Let's set up the metric that will count all the requests made from the Android devices. So we have 3 objects here. First of all, it's rule that will match for our header, so when it has Android inside it. Then it will form the metric using this object metric. It will set the value 1 with the message hello Java meetup. And then we'll send this metric to the Prometheus. So it's for our adapter. Let's apply this metric. Okay, custom metric. It's applied. Let's emulate some requests made from Android. Or if somebody uses Android, you can also simulate this. Okay. It's loading pretty slow. Okay, I guess the requests are made. So for now, I will do that. You can see it. We can see that we have. I have to refresh the Prometheus. Istio Android request count. So we have this metric, and we can see how much requests were made for what service for Android. So it's also pretty easy. Okay, let's go to some more advanced thing that you have to do sometimes. So suppose that we have some bug. It's reproduced only in production. You cannot reproduce it locally, and you have no idea where this bug comes from, how to fix it. What do you do in this case? Any ideas? Sometimes watching logs, but usually logs wrote some colleague that already doesn't work in this company and you don't know how to talk with them. You know that logging is bad. Sorry? It's not reproduced locally, only with the production traffic. So, any other ideas? Could be, but monitoring tools tells that everything's okay, so, or metrics are bad. Some other ideas? Sorry? Yeah, but there is some credit cards information or some personal information, you know, so, and GDPR and stuff, so they won't provide you.
Most likely you can ask Istio to record traffic, right?
You can, but I was talking about something else, about debugging. So we can debug remotely, except that the case that you have to open the ports for it and it's not really secure.
Spring Cloud supports remote debugging, by the way.
Yeah, I guess, yes. But with Istio, you can remotely debugging locally. I will show you how to do that. First of all, we have to start our service. So you can see here how my service looks like. No Spring, no frameworks, just Java 11. I'm open HTTP service on port 8081. And I'm having my service that returns me like a random quote. Okay, let's start this in debug. Okay, it's started. So I can go to localhost 8081/quote, or I can't. Oh, it's 8180, but it should be 8081. All right, so you can see that my application is working, and I'm getting here the quote from my application. Then I will use a tool that is called ngrok. I don't know if any of you heard of this tool, but with this tool you can like open your local machine to the outside world. So I'll use ngrok http 8081, and it will give me the URL to connect it from outside the world. So I can connect from everywhere to my local machine. So let's change my local host to this, and you can see that I'm still getting this request. The next thing that I have to do is to apply some service entry that will allow traffic from outside to outside of our cluster. So I will set here the host to this ngrok URL and virtual service that will redirect the traffic to this URL in case if I have this xdebug header set to true. So let's apply this. kubectl apply. Not appear sources. Debugger right. Okay. Okay, so it's created. Good. Now I can click refresh. Nothing happens because I'm not setting this header. So let me send the same request, but with this header. And you can see from the cluster that is deployed on the Google Cloud, I redirect the traffic to my local machine. So I can debug it for now. Let's, for this, let's change my quote. Okay, so I cannot set in debug. Okay, whatever. So you can see that we can debug it. So from outside our cluster. I don't get image because my image service is not started. So, okay, one more tool that I want to show you is this one. It works only with Istio. It's also for monitoring, but it also is for seeing the Istio configuration. So if some of my configuration is not valid, you can see in this tool called Kiali that something is wrong and your configuration is not correct. So if something is not working with Istio, this is the first place you have to look at. Beside that, this tool have really cool feature. So if you're not using Istio, you will lose this feature. So only because of this feature, I will suggest you to use Istio, this one. You can see. It's traffic animation. More of that. you can see some logs when your traffic is encrypted. So if you're not using Istio, you cannot see this on your production machine, on your production environment. So use Istio, then you can use Kiali, and you can see this nice animation. Okay, that's a joke, because Kiali is a really cool thing, and you can, for instance, you can see that the health of your cluster, of your service is not okay because we injected some errors and some delays, and we received the error. You can set up all of these routing rules that we already set. You can change it. Okay, so service version 1. You can see here, just a minute, I'll go through here. Let's start service. So you can see the endpoints, you can see the health. So it's really nice debugging tool, but it works only with Istio. Okay, so that's it for my demo. Let's go back to presentation. I hope that it will work. It does. All right, so the summary. What Istio gives us? First of all, it's a possibility to focus on business logic. With Istio, you don't have to worry about solving all the infrastructure thing that you will solve in any microservice application. Second is you can choose any technology stack. You're not you shouldn't stick like to Spring Cloud or any other framework. Even you shouldn't stick to one language because Istio is polyglot. You get observability out of the box. You saw all the metrics, all the tracing. In the same stuff you can do logging. And it solves most of microservices problems, but you have to remember that not all of them, because we develop the microservice application and we are responsible for it to work correctly. So we are the ones who solves problem, not the Istio, not Spring Boot, not Spring Cloud, not Kubernetes. So if something goes wrong, you cannot blame Istio. So here are some resources where you can learn more about Istio. Beside that, here, down below, you can see the link to my demo. You can run it on some cloud. You can run it locally on Minikube or Docker for desktop. So about the resources, it's official Istio site. It's Istio in Action book by Christian Posta. This is the man who knows everything about Service Mesh. This is the only man in the world who knows everything about Service Mesh. And he also have a blog that he wrote about Service Mesh, about Istio. And Red Hat development blog, it has a topic dedicated to Service Mesh, mostly to Istio, because the Red Hat is one of the main contributors to Istio. I already shared these slides on my Twitter, so be sure to follow me. And you can see the slides and the link to my demo in Twitter. So thank you. If you have any question, I will be glad to answer you. Yes, please. Wait for a microphone.
Okay, thank you. I have a question about Istio deployment.
Maybe you have to turn it on because I can hear you, but I'm not sure that. Okay.
One question about Istio deployment. From your presentation, looks like Istio is built on the top of Kubernetes, so you don't need separate deployment for it. But do you need to deploy it on separate instances to build some quorum, or how it can be deployed to production environment?
To deploy Istio, you have to deploy a bunch of components, like for control plane. This is the first thing you have to do. So it's built like alongside Kubernetes. So you can just deploy it, and your services won't break. It just will run inside of your cluster. Then there are two options. You can deploy it using Istio inject command that will change your deployment and will set it to have already this proxy injected in it. And the second one is the one that I have used. I just set the label to my namespace, and all the new deployments that you have, Istio will automatically inject it, the proxy inside it. And in this case, you just set this one. Then you do rolling deployment, so your user won't experience any downtime. So the new pods will be injected. The old pods will be eliminated from your cluster. You won't have any downtime, and you will have Istio injected. So hope that I have answered your question. I was trying to explain it as much as I can. Okay.
Are you free to use any Docker image with Istio, or there are some special cases?
Sorry, I didn't get the first word.
Can you deploy Istio virtually to any Docker image?
It's not deployed to the Docker image itself. So because it's working mostly with Kubernetes, so it operates with the pod in the Kubernetes. So pod is one or more containers. So in my case, I have one container with my service, the second container with Envoy proxy. So it just inject another container with Envoy proxy, and it lives in the same pod, so it talks like via localhost to each other. So you don't have to change your Docker image for that. Okay, any other questions? Yes, please.
Have you had an experience using it with NATS system for messaging? Because before there were some, let's say so, incompatibilities, you know, like using Istio with NATS.
So you mean like some messaging systems like Kafka, Rabbit or something?
No, NATS. Have you heard about it? Like message system for microservices?
I have heard of it, but I didn't use it. But it actually doesn't matter. I suppose it's TCP traffic, right? So it's not HTTP traffic.
Yeah.
Okay, so if you Istio supports TCP traffic, it supports HTTP 101.2.0. It supports gRPC, which is like built on top of HTTP 2.0. It supports WebSocket, MongoDB, and it supports pure TCP traffic. With the pure TCP traffic, you will lose a lot of features of Istio because, as you can see, it operates on some protocol-specific stuff. Like in case of HTTP, it's headers. So if it's just some TCP traffic, it cannot operate with it. So like it will send it, it will forward it, but you cannot match on headers on TCP traffic because Istio have no idea what traffic it is, how to like decrypt it and stuff. It will work with that, but you lose some features of Istio. Okay, some other questions? Yes, please. So like there are some prizes for the best questions, so ask more actively. Yes.
Thank you. What about monolithic project? Can we use Istio with monolith project?
Yes, you can if it's containerized or if it runs on Kubernetes. So it's possible. They like have some marketing stuff like where they support legacy projects. They explain how it can contribute to legacy projects, but I haven't seen a monolithic application run in the Kubernetes. I haven't worked with such application. So theoretically, it's possible, but I cannot answer on practice on that.
Thanks.
Okay, some other questions? Yes, please.
Are there any downside of using Istio?
Yes, of course, because it's another tool that you have to support. So if something goes wrong, it's one more place where you have to debug. So of course, you have like one more level of abstraction, but it's also one more level where something can go wrong. So this is one downside. Another downside is that you have, as you have like more hops, like it goes through your proxy, you have some latency delay. It's not very big for most of the projects, but there could be projects where it could be critical. So in this case, you can disable mixer component. You will lose a set of feature of Istio, but without mixer component, it works faster. Also, they are working on moving some feature from mixer to the proxy itself that will also fasten like the requests. So for now, if we are looking at the benchmark from their official site, they said that in the deployment where you have 1,000 services with 7,000 requests per second inside all the cluster, like not only inside the cluster. You will receive 8 milliseconds delay on 90%. So it's not very big, but in some projects it could be crucial. So.
Thank you. And one more, can I ask? What about resources? So basically we have two containers, our application and container with Envoy. And if we have all of the Envoy in all our services, so what about the amount of resources that is used by this bunch
of course, it will use more resources. So for Envoy, it's not very big because Envoy is built in C++, so it's like nice and fancy and it's very quick and stuff. For control plane, there are some, in some cases, some significant amount of resources that it uses. So you can read on their official site. They have like a benchmark that will explain everything about the resources, in which cases how much resources is used, how much latency it adds, and stuff like this. So of course, it will use more resources.
And one more, please. Is there a way to, is there some component that allows you to have A/B testing, not to implement custom one, but out of the box in Istio?
So for A/B testing, like out of the box in Istio, it's
for
like
example,
yeah.
Sorry for interruption. For example, to know which version of our application get better responses from our customers.
Yeah, I understand. So Istio out of the box does not provide it. But it has a lot of adapters to another tools, so to the third-party tools, like Prometheus, for example. So you can set up some alarming on Prometheus that will like alarm you if something goes wrong. Or there is a tool called Flagger that can do this more advanced, but I haven't used it, so I cannot recommend or not recommend it to you. But it's used quite widely for now. So Istio just can redirect it to adapters, so it's like a third-party applications that can do it for you. So Prometheus is an example.
So basically there are good options to choose from, yeah?
Yes, yes. So there are a lot of adapters already built into Istio that it supports. And you can develop your own adapter. So they have, I'm not sure it's in the documentation, but there are some blog posts how to build adapters. So you can just take a look at it and build your own.
So as I understand, if you want this, you better make it yourself. There is
No, so it's you can make yourself if there are no adapters for your users. For now, there is for Flagger and for Prometheus. So this are the good options. If it does not meet your requirements, then you can build your own. Yes. Okay. Any other questions? Okay. No more questions. So okay, which prize I can give off? Okay. So do you want a bag or a bag? Okay, so you asked more questions, so here. Okay, so thank you all for coming. That's it. Thanks.